As it turns out, I'm right about that. So this glutamate dehydrogenase is going to change glutamate into alpha-ketoglutarate. All right? This is going to go to the TCA cycle. The only difference between alpha-ketoglutarate and glutamate is a single ammonium group. So once they break apart, this ammonium group is going to go to the urea cycle for destruction or potentially to synthesize new amino acids. In this case, the body is probably in a catabolic state because it's breaking down and creating ammonium in the extrahepatic tissues. It's most likely going to go to the urea cycle. I'm doubting it's going to be synthesizing new amino acids at that point in time. So that's essentially that. A good example of this is in skeletal muscle. Now what happens in skeletal muscle, we have something called a transamination reaction. What a transamination is, exactly what it sounds like. You're taking an amino group, transamine, you're transporting it from one location to another. Transporting an amino group to somewhere else. What this is going to look like is we've got alpha-ketoglutarate that's kind of present in all cells in the TCA cycle, and we've got an amino acid. In this case, we know about the amino acid alanine, so that's the example we're going to use. What happens in this transamination reaction is we're going to take the alpha amine group from alanine and we're going to tack it onto alpha-ketoglutarate. What's that going to make? That's going to give us glutamate. Because our alanine is an alpha-keto acid, it has an alpha-keto acid, so as soon as it is deaminoed, as soon as the amino group is gone, it's going to form pyruvate. This pyruvate and this glutamate are both going to go from the skeletal muscle, because we're in skeletal muscle right now, it's going to go from skeletal muscle into the liver. Once in the liver, glutamate will be, it's going to lose that amine group, ammonium group. Our pyruvate is going to be channeled into gluconeogenesis. Gluconeogenesis? It is gluconeogenesis. Bam. NH4, this NH4 is going to go to the urea cycle. Once we lose NH4, again, we've got that alpha-ketoglutarate, which is going to go to the TCA cycle, tricarboxylic acid cycle. Now, the enzyme that does this is termed alanine amino transferase. Now this makes a lot of sense. What is it doing? It's taking an amino group from alanine and transferring it onto alpha-ketoglutarate. Alanine amino transferase. Makes a lot of sense. It's kind of perfect that way. Our next video is going to go into the urea cycle, but really quickly, transamination reactions all rely on one vitamin. That vitamin, just making sure I'm not screwing with you here, that vitamin, these amino transferases, are all going to be PLP dependent. What is that? That is pyridoxal pyridoxal phosphate. Pyridoxal phosphate is reliant on the vitamin pyridoxine. No way, pyridoxine, which is in fact vitamin B6. That has been amino acid catabolism. As for how the individual amino acids break down, I'm going to do another video of that. Awesome.